Hello everyone, thank you for your interest in our research. I'm Yang Wang, a PhD student from University of Liverpool. My supervisors are Asteros Agakastis and Andrew Crowton. This paper is one chapter of my PhD thesis, which is titled Translating Fengshui into Algorithmic Design, a digital tool to examine the impact of Fengshui on the Siheyuan's layout. Fengshui is a Chinese geomancy that predicts the householder's fortune by observing the houses he or she lives in. Fengshui embodies the ancient Chinese philosophy originated from I Ching, the ancient Chinese literature looking at the understanding of the universe. Siheyuan, namely quadrangle in English, is a traditional Chinese courtyard building type. The design of this typology are constrained by Fuzhou etiquette, one of which is feng shui. These constraints caused many morphological characteristics of Siheyuan. The figure 1 shows a lot of examples of built Siheyuan in Beijing. The figure 2 shows an ideal three-courtyard Siheyuan. It's noted the principle of feng shui were parametrically and computationally based. The feng shui influenced the form of Siheyuan design. It's one factor that caused the variance of this typology. Figure 3 shows variance of Siheyuan plan in scale and decorative details. We addressed the three research questions. The first is how do feng shui principles influence Siheyuan design? The second, how can these principles be implemented into algorithm design and be applied as an interactive tool for examining the fortune of a Siheyuan house? Third, were these principles being applied in traditional Siheyuan design practice? To answer these three research questions, when formulated our methodology in three stages. First, we studied the feng shui story based on historical material and interviews with feng shui geomancers to clarify the original principles relating to Siheyuan design. Then we have analyzed the computational logic underlying its principles to produce an algorithm by the grasshopper visual scripting. And finally, when have employed this algorithm as a tool to examine the fortune of historical Siheyuan cases whose corpus has derived from ensuring surveys of extant Siheyuan examples and documented historical examples. The feng shui contains two branches. The first is called Xingshi, which is translated as observing context in English. For the details of this branch, please see our another paper. The title is shown on the top left. The second is Li Qi, which is focused on in this research. Feng Shui geomancers supposed a kind of mysterious energy called qi flows in the air in the form of invisible gas. This gas brings good fortune to people. Li Qi is a method to steer this energy. In the case of Siheyuan, the proper size, ratios, dimensions, and rotation of rooms can store this energy in the house space. Therefore, in this paper, we are concerned on the three aspects: room orientation, room size ratio, and room dimensions. For the room orientations, the feng shui rules contain two constraints. First is called being within the auspicious degree ranges of orientation. The first constraint requires the elevation of the primary room of each courtyard in Siheyuan orientated within the range of auspicious degrees. The simplest way to find the auspicious degree is to use a feng shui corpus which averagely divides a two-dimensional plan into 24 sections called 24 mountains by 15 degrees and additionally divides each section into 5 subsections by 3 degrees as shown in figure 5. Degrees located within each second and fourth subsections are defined as auspicious orientations. The second constraint is facing an adjacent street or alley. The second requires the principal room orientated to an adjacent street or alley. Further, a second aspect of the room size ratio, there is a series of computational procedures to identify the room size ratios. The procedures were parametrically rule-based, whose parameter is the location of the entry gate within one of the light squares on the courtyard plan. When showed two examples of the procedural process. The one is for the one courtyard 四合院 and the other one is for three courtyards 四合院. The final results identify the fortune of each square and the degree of the fortune. This constrains that the larger rooms locate on more auspicious squares and the smaller rooms locates on more ominous squares. There is also a series of computational procedures to identify the room dimensions. It's also parametrically rule-based, whose parameter is the orientation of the room. Using the computational procedures, the auspicious ranges of dimensions of a room's height, width, and depth could be identified. The room dimensions should be within the auspicious range. Based on the analysis of the computability of Fengshui, when translated the rules into an algorithm and implemented it in Grasshopper to examine if the built 四合院 examples are auspicious. When examined the four selected examples of 四合院, in the three aspects: the room scale ratio, the room orientation, and the room dimensions, our conclusions contains six aspects. First, the four examples are mostly auspicious. Second, other influence more important than feng shui are also at work. Third, to make 四合院 conform to feng shui, ancient craftsmen would slightly change the room size to ensure size ratios of rooms are in auspicious patterns, which is hard to prove without conducting a measuring survey. Fourth, feng shui rules were simplified in practice to solve the difficulty in building construction. Fifth, it's too hard to ideally follow feng shui rules, but the craftsmen did their best to try to meet the most of these rules. And finally, computability of feng shui principles is confirmed by this research. Thank you for listening. For any questions, please email me.